Good evening to one and all present here. I am Dr. K. Kannan, Assistant Professor, Department of Computer Science, Dr. SNS Rajalakshmi College of Arts and Science, Coimbatore. Today we are discuss about the understanding the ACID properties in database management system. Today we are going to see the understanding of ACT properties in DBMS agenda is the introduction to ACIT properties and atomicity and consistency, isolation, durability, and ACIT properties in real world application, and ACIT with base properties and the benefits of ACIT properties, and challenges and limitations, and ACIT in modern databases. Okay. Uh, First, we discuss about the understanding the ACIT properties in future of ACIT properties, and we have the conclusion for the ACIT properties. And first of all, we discuss about what is the introduction to ACIT properties. There are three defined the ACIT properties. First one is the atomicity defined. The atomicity is nothing but it guarantees that the transaction in all or nothing, ensuring the complete execution or no changes, and it is a guarantee to transaction to all the data easily. We can automatically send the data and defining the data. That is the main reason of atomicity is defined. The next one is what is the consistency explained. The consistency is ensure the data validity and transforming the database from one valid state to another after transactions. And durability of overview, it is assets that once a transaction is successfully complete, it changes the remain permanent despite of failures. Next one is we are deep discussion about what is the atomicity. There are three role of this transaction process. The first one is understanding transaction rollback. In case of some of the transaction is failure, a rollback of restore the database to its pre-transaction the state is automatically. Next one is real world example I given. For instance of transferring the fund, the accounts is explains the atomicity. They require the complete the success and rotate the sum of total of the failures. The automatically the accounts will be retransferring funds from this account. This is a real world example. The next one is what is the importance in the reliability. The atomicity is vital for the preventing the partial updates that could lead to data corruption and inconsistency. Next, we discuss about what is the consistency. That there are three type of role we have discussed, and defining the consistency and role in data integrity. Example of constraints. The consistency of ensure the data transaction. The only the alter data in way that adhere to define the constraints. The next one is the role in data integrity. The maintaining the integrity consistencies prevents the illegal states through they enforce the rules on the database transitions. The example of constraints, for instance of a unique constraint is stop the duplicate entries, the sustaining the accuracy of store the informations. Next one is what is the isolation. The isolation is explained to ensure the transaction they execute the independently, the minimizing the potential for interference between the concurrent operations. The preventing the dirty reads through the isolation system avoid the dirty reads, ensuring the data transaction do not access the uncommitted data from others, and impact on the performance. While enhancing data integrity, the strict isolation may affect the performance by reducing the concurrency in transaction processing. The next one is what is the durability. The defining the durability is guaranteed transaction. The performance is despite of failures. The ensuring the committed of changes to the survey system. The disruption of outages. The power outages, for examples, it is consider the bank transfer. If power outages occur the post commit, the changes remain intact and retrievable. Next one is critical role in system. The durability is essential for user trust, assuring that critical transaction are reliable and preserved amidst of the failures. Next one is the ACID properties in real world applications. The first one is the ACID in banking system. In banking, is ACID properties is ensure that every transaction that maintains the integrity, the preventing the data loss during the monetary of exchanges and e-commerce applications. The e-commerce platforms leverage the ACID principle to the secure the transaction, the improving the customer confidence and safeguarding the sensitive the information. The real time of impact, the implementing the ACID, the real time processing is minimizing the risk during the high volume of transaction and periods on various online platforms. Next one is what is the ACID's base properties. The overview of base properties is emphasis of availability and eventual of consistency, the allowing the trade-off for loosened of constrained databases and a comparison with ACID. Unlike the ACID's strictness, base favors and flexibility, promoting the speed and availability at the cost and immediate consistency. Some of the use case of base common use, the case including a distributed system and application is demanding the high availability like social network and IoT platforms. The benefits of ACID properties, the enhance the data reliability and implementing the ACID ensure that the transaction are committed reliably, reducing the risk of data loss significantly. Next one is integrity maintenance. The ACID principle is enforce the rules preventing the violations, thereby the maintaining the data integrity across the complex transactional system and prevention of data anomalies by adhering the ACID is typical anomalies such as lost updates or dirty reads are effectively mitigated. Some of the challenges and limitations, the performance is overhead and